Okay, so here's Chapter 4 PowerPoint, Part 2. El Nino, also known as El Nino Southern Oscillation, I believe it is. El Nino occurs about every 3 to 7 years. Some people say more like could be 8 years. What actually happens is the winds that blow across the Pacific towards Japan and Asia, they weaken. And normally what happens is they blow across and they basically push all the warm water over to the western side of the Pacific. And when those trade winds weaken, they can't push that big bulge of water over there anymore. And so that warm water actually kind of sloshes back towards the eastern Pacific Ocean. So you get what usually is cold water along the eastern Pacific coast of North and South America. You get this warm water that sloshes back over there and it becomes much warmer. That creates a lot of weird weather patterns there. You get a lot more rain, you get a lot more storms, a lot more flooding, landslides, that kind of thing. And you can also get a reduction in your coastal fish populations because fish like that, the fish along that area like that cold weather. So you get this kind of bad situation going on. Consequences of El Nino, you get cooler, wetter situations in the United States, the southeast US, storms, heavy rains, mudslides, that kind of thing. You get drier than usual conditions in Asia and Africa, even droughts. Sunnier in the northwest US. The jet stream drops further south, so you get less hurricanes in the Atlantic, and you can get flooding in Peru and Chile because they get a lot of rain. Of course, you also get a reduction in fish population, so your fisheries decrease. So basically the picture on the top is a normal situation and on the bottom is kind of the El Nino, so this water gets sloshed back. We're going to go through this in class, so I'm not going to spend much time on this. Rain shadow effect, this is really kind of a cool thing. Basically you get water coming on shore from the ocean. That water is usually kind of warm and wet, picking up humidity from the ocean. When it hits coasts that have a mountain range near the coast, that warm air starts to go up the mountain range as it interacts with the mountain range, and you get adiabatic cooling. So you're going to get clouds and precipitation. So on the windward, the ocean side, you're going to get you're going to get forests. You're going to get lots of humidity and cooler temperatures or nice temperatures. And you're going to get forests. Once that air goes up and over the mountain, it's dropped all its precipitation, so now it's dry. And of course, it's going to go through adiabatic heating as it comes down and increases in pressure. And so you're going to get warm, dry air on the other side of the mountain. So you get arid conditions. You get rain or deserts basically, and this is the rain shadow effect. Go look at a map of the western United States, and we have the Sierra Nevadas that run all the way up through California and everything, and the ocean side, nice forests, wet, kind of things. The other side, you have desert. Okay, so there's your rain shadow effect. Again, air goes up, dumps all its rain, all its precipitation, and then goes over, and you have deserts on the other side. Okay, couple other things. These are not in the book, or this is some stuff that I've added. Weather fronts. A front is a boundary between two air masses. If you have a cold front, you have cold dense air that's advancing on a warm mass. This causes our big thunderstorms. You get clouds like in the picture that kind of look like anvils. Because cold air is more dense, it kind of tries to kind of power it out, and you get severe storms. If you have a warm front, you get warm air that is advancing on the cold air. It's running into the cold air, and so you get clouds, but you get the drizzly rain. So next time we have drizzly rain, you know it's a warm front, and if you see the cold front coming, you know we're going to have some severe storms. Tropical cyclones, these are hurricanes or typhoons. The only difference between a hurricane and typhoon, we call them hurricanes in the Atlantic and we call them typhoons in the Pacific. They're still a spiral storm. Damaging winds and storm surge. Storm surge is a pile of water that is pushed up in front of them as they go. And it can cause a lot of flooding and damage. Large amounts of precipitation, of course, and high winds, and then they can spawn off tornadoes and create tornadoes. Hurricane Katrina, we just went through a hurricane, but Hurricane Katrina in 2005 that hit New Orleans had a 29-foot storm surge and 145-mile-per-hour winds, which is why they had severe damage and flooding. Tornadoes occur when there's a strong, dry, cold front and it collides with a warm, humid front. These change in temperatures can actually cause a rotation and you get severe tornadoes. The greater the difference between the two temperatures of the two masses, the dry mass and the warm, humid mass, the more severe the tornadoes will be. So kind of the more energy they'll have. Okay, moving on to biomes. Terrestrial biomes. Climate, which is your amount of precipitation and temperature, determine what kind of plants there. The type of plants determines the animals. Biomes are determined by the plants. So we look at the type of plants, we look at the temperature and precipitation, and we get the biomes. Not all biomes, not all deciduous forests have the same plants, but the plants are very similar in structure and function and adaptation. Maybe not the same species, but very similar. So climate, things you should know about the biomes. Climate, soil, and vegetation, what kind of plants and stuff are there, what limits their growth. Latitude, basically at the equator you have tropical biomes, further up you have temperate, and then when you get to the poles you have polar biomes. You also get biomes by altitude. As you go vertically up a mountain, you get them. So if you have a tall enough mountain, you can get the tundra at the top of a mountain, even if it's along the equator. Okay, so a tundra. Tundra is also known as Arctic tundra or polar grasslands or alpine tundra. Alpine tundra is what we call it when it's on the top of a mountain. Precipitation is less than 10 centimeters per year. Temperature is somewhere between -20 and 10 degrees Celsius, so relatively cool year-round. Organic material is slow to decompose because it's so cold. It has a very short growing season and it has very low biodiversity because most organisms cannot withstand this. Many organisms, animals will migrate into this area for the summer to feed on some of this stuff and all, but that's about it. Not many things live there. The soil is thin. It has permafrost layer underneath it. It's only basically thawed in the summer. The soil is very young because it takes a lot of time to actually increase your soil. We'll talk more about that when we get to soil. The soil is nutrient poor because there's very little organic matter decomposing to add nutrients to it. It's frozen most of the year. It's very soggy. It's like walking on a sponge during the summer. Because there's the permafrost underneath that traps the melted ice on top and makes it very slushy. The plants and the adaptations, lichens, moss, sedges, dwarf bushes, little short growing stuff, hardy stuff. They reproduce very quickly in the growing season because they have a very short growing season, so they grow a little and reproduce and they're done. 3 months, that's all they get. The organisms in the tundra, you have insects, you have migratory waterfowl, terns, which are birds, lots of shorebirds, little songbirds, lemmings, small, kind of little rodent-y guy, Arctic hares, your Arctic foxes, smaller animals. You have your reindeer, your muskox, your caribou, and they'll come into these areas, and the wolves will follow them for the summer, but only for the summer. Major human interferences. It's too cold for most humans to be up there. We don't like that. A few people are crazy enough to be up there, but we do go up there for oil and natural gas drilling and transport those things. And then of course global warming is having an impact and actually resulting in a lot of methane. Okay, so a picture of the tundra, where it is. Okay, the other polar biome is the boreal forest, also known as the taiga. I had to think there for a second, even though it's written on the slide. Or the northern coniferous forest. Conifers are your pine trees, cone-bearing trees, so your pine trees. Precipitation, temperature, pretty low. Soil, it's acidic, lots of litter. The pine needles actually make it acidic. The plants that grow there, again, lots of pine trees. Maybe a few deciduous, but not much. It's mostly pine. And they have a very slow growing season, very short growing season, because again, they're still a polar habitat. Organisms that live there: bear, moose, migratory birds. Human interference: logging, mining, fur trade, dams. We like to dam the rivers. That affects the habitats. And there they are, although I love it. Okay. Temperate rainforest. We'll get through the temperates and then yeah. Okay, also known as cloud forest. Very cool area. If you've ever been up to Washington State on the out on the Olympic Peninsula, that's what we have out there. It's a coastal biome. You only find it along coastlines. Lots and lots of rain. Very foggy. Sorry for the cough. Lots of condensation on the leaves and stuff. The leaves are always drippy. Everything's always wet. Very mild year-round temperatures because of the ocean presence. It helps moderate the temperatures and make sure that they're cool. The soils are old, they're thin, they're acidic, because again, a lot of pine trees again. And they're nutrient poor because of leaching. There's enough rain that it leaches the nutrients out of them. Same kind of thing, lots of conifers, and then a few of your deciduous plants. Elk, deer, cougar, puma, mountain lion, whatever you want to call them. Bears, small mammals, birds, lots of birds. Northern spotted owl. Been a lot of issues with the northern spotted owl and logging areas. Human interference, logging, and damming, which has interfered with our salmon. Again, there it is up in Washington. Again, Australia, tips of South America. That's where you're going to find it, coastal areas. That's a very rare habitat. Okay, tropical seasonal forest, also known as savannas, where the lions prowl. Distinct wet wet and dry seasons. Goodness gracious, now I'm coughing. Okay. But decently wet. Nice warm temperatures. We're now in the tropical biomes. Why did we skip? Okay, well, this is a tropical biome. Higher nutrient soil, higher than the tropical rainforest because there's less plants and there's a lot of decomposition of grasses and stuff. Slightly acidic soil, and highly leached again because there's quite a bit of rain. Still, the savanna, deciduous trees. In the savanna areas, a lot of times the elephants are knocking down the trees, so there's not a lot of them. Lots of insects, amphibians, reptiles. In Australia, this is where you're going to find your koala and stuff. Impacted by humans for logging, agriculture, lots of invasive species, because we introduce plants in these areas, and they do well. Grazing by livestock, and then, of course, damming rivers. Okay. Actually, I'm going to cut this off here, and I will do the second one next.